So in this video, we're going to be discussing state reducers in LangGraph. We're going to be discussing it, and we're also going to be looking at some demos in code. Now, if you watched the state schema video or the Graph API introduction video, you definitely have heard something about, I heard me mention reducers. If you have not, go watch those videos. Now, if you've heard me talk about reducers. Now, state variables are variables. So that means they're not static, they can change. So we need something to update them, and nodes help us update state variables. State variables are updated through our nodes, but you can define, or something manages how they are updated. Something is responsible for how these state variables are updated, and that's the reducer. The function of the reducer is to determine how a state variable is updated, so that when a node returns a new update for the state variable, the reducer is then called upon to manage that update. But to understand better how things work, let us head into our whiteboard. So let's say we have our states. Let's say we have a bunch of states here. Let us just use from our previous example, let's say messages. So messages is a list. Messages is a list. It's an empty list. Then we also have step count. We have step count. Step count is an integer and it starts from 0. Then we have private data. Private data is just a string. It's just a string. Private data is a string. And it's empty. Yeah, it's an empty string. So we have these state variables. We have these variables in our state. Now, these don't represent anything, so don't try and figure out what this what these all mean or what's related with. These don't represent anything. We just need a bunch of variables to work with. So we have these three variables, and through nodes, through each node, they need to change. So from one node to another, from one node A to another node B, this need to change. They need to change, and you can choose to change one of them, multiple of them, or all of them. Now, how they change is the responsibility of the reducer. Yeah, the reducer takes care of how they change. Now, the thing with LangGraph is that if you don't define any reducer, there's a default reducer already in effect. Yeah, there's a default reducer already in effect. Now, what this default reducer does is that whenever you return a new value for a particular state variable, the existing value will be overridden by the new value. The new value is going to override the existing value. So let's say for messages, we bring in a new value. Let's say we have a new array. Sorry, I keep calling it array a lot because of my JavaScript background. A new list. So let's say we come with a new list, and the list says step 1. Set as a new list, say step 1, and it's the update for this particular variable. This entire list is going to be replaced with this value. The entire list is going to be replaced with this value. So it then becomes, this then becomes step 1. Becomes step 1. Now, if another node, let's say node B, updates this variable once again, and let's say it says step 32, you are not going to have step 32 added to this list. No, you're not going to have it like this. You won't. This new value, step 32, is going to come here and override the existing list. It's going to override this entire list. It's going to override it. It's going to override this entire list. And the same goes for step count also. If you have a new value for step count, let's say you have a value 5 for step count, and that is returned by a node as the update to step count. Step count automatically is going to be changed to 5. It's going to be changed to 5. Even though going by the name step count, you kind of want to increment it. Sometimes you want to replace it. Probably that's what you want to do with your integer state variable. For a value like step count, what we actually want to do is increment it. And if you just return a new value to it from a node, that value is not going to be, the existing value is not going to be incremented by the new value. It is just going to override it. So this will automatically become 5. That's how the default reducer works. That's how the default reducer works. works. So in cases where that's the behavior you want, you can just leave things as is. You can just leave it. You don't need to change anything. You don't need to write any custom reducer or use LangGraph's built-in reducers. Just leave it that way and it will just function fine. However, if you need data to be manipulated in your own way, you want to define how each state variable is to be changed, then you need to define something called a custom reducer. You need to define a custom reducer. Now, a custom reducer is basically a Python function. So, whether you are using Python or JavaScript SDK, but it's a function. We're assuming Python SDK here. It's a function. Let's say change step count. So your default to your custom reducer rather is a function, and that function would take two values. It's taking two values. Let me just put a center stage here. Let's bring this down. Let's bring the function here. Okay, good. So we have our function. Let me give you some color. So we have this function, and it's going to take in two values: the current value of that state variable and the new value being returned by a node. The current value of the state variable and the new value being returned by the node. That is what it's going to give you to work with. So you can then take this function, and inside this function, you can define how you want the update to be done. You can define how you want the update to be done. For our step count, we want to say return current plus new, because we just want to increment it by the new value that comes in. But you can define anything here. You can define anything, any strategy that you want your update to take. You can define it here. They're just normal functions. So anything you can do in a function, you can do it. So that's what you do here. That's what you do in your custom reducer. So this is how you define a custom reducer. It's basically a function. And once you have it defined, in your state definition, let's say this is a state definition, you need to annotate your state definition using the annotated class. You need to annotate it. So first you give it your data type. This is a list. Then you pass in your custom reducer. So you can just say custom reducer. Or I'm just going to say C reducer to manage space. So you pass in your custom reducer. That's how you set custom reducers. Once you have them defined, you set them using the annotated class. So that's how the reducers work. So you can either use the default reducer or use a custom reducer. Now, before we go into our demo, LangGraph also provides a reducer. There's a special reducer that LangGraph provides. And this is because a bunch of times you're going to be working with LLMs. I'm going to be working with a list of conversational messages. So LangGraph provides a way for you to manage these messages, this list of messages, with a special reducer called add messages. Add messages. Special reducer called add messages. So LangGraph provides this reducer. If you know that one of your state variables is a list of LLM messages, just use add messages. It's going to help you manage the entire chat history within your LLM interactions. So we're also going to be seeing how to use that in another video. Not in this video. We're going to be seeing how to use that in another video. But now that we understand how reducers work, let us go into VS Code and check it out. So now here in VS Code, let us have a simple demo of how we can use reducers with our agent state. Now the demo we're going to be using in this example starts with a function. We'll define a function that does something similar to what we did when we were working with agent schemas, which is a function that just builds a graph that we can work with so that we don't have to create a graph over and over again for the different examples that we're going to be working with. So let us quickly walk through this function. It's called one example, and it takes in a name. This is just a string name for the demo that we're doing. Then a state schema, which is a schema that we defined, and also a node func argument, which is basically the only node that we're going to be using in this example, which is a simple node that just updates the state. We're not going to be doing two nodes, or just one node is okay for this. And also we pass in an initial state for our example. So inside this function, we have a print statement here that just tells us the example that we're running. Then we create our graph with state graph by passing it our schema. Once we have that, we add our node, which is the only node that we're going to be using in this example. It's called update node. So we add it as node func. which is the argument that comes in from here. Then we start with an edge that goes from the standard start node to the update node, and then another edge which goes from the update node to the end node. So our graph is basically a straight line. It goes from start to update node and from update node to end. Then we compile our graph and generate a final state for our operation by calling invoke on our graph and passing it the initial state. Then finally we just print out the initial state and the final state so that we can compare both. So that's basically our function, and we're going to be passing it our state, any state that we create, whether we're going to be creating state that doesn't have any reducer, and we're going to be creating state that has reducer. So we're just going to be passing that state definition inside. We're also going to pass the node that we use for the operation, and it's just going to help us run the graph. So to start our very first example, let us begin. The first example is going to be a state that has no reducer, a state definition with no reducer. Now our state will contain two state variables, two simple state variables, count and animals. Count and animals. Count is going to be an integer that we expect to increment, and animals is just going to be a list of strings. So we're going to be using both. We're going to be using these two state variables to define our state, and we're going to be looking at them with and without reducers. So first, let us start without reducers. So let's say without reducer, and to define the state, I'm going to be bringing some guys in from the typing library. That will be the annotated class, the list class, and the typed dict class. So bring those three in, and as you may have guessed, we want to use type dict to create our state. So I'm just going to create the state without reducers. I'm going to call it state without reducer. It's going to inherit from typed dict, and it's going to have two state variables, count, which, as I've mentioned, is just going to be an integer, and we're not going to add any reducer, so that will be fine. We have an integer. We need, we're not adding a reducer, so we don't need. Then we're going to have animals, and that will be a list of strings. A list of strings. So these are our state, and it doesn't have a reducer. There's no reducer added. That's why we didn't use the annotated class. There's no reducer added to this. Let us run this and see what we get. First, let us create the node that will help us update it. So I'm going to say node to update. It's taking our state, and this state will be of the instance state without reducer. So state without reducer. We're going to return a dictionary, because that is what we expect to return from our node to update the state. So return a dictionary, and inside here, we're simply just going to return updates. So for the count, I want it to now be 1. And for animals, I hope to add a cat. For animals, I hope to add a cat. So count, update it to 1, animals, make a cat. So that's good. Finally, let us create the initial state that is going to be defining where our starting point, the starting point of our state. So we'll start with count. And let's say I want to start count from 5. Let's say I want to start count from 5. And for animals, let's just have a lion and a buffalo there. So lion and buffalo. So I'm starting my count at 5. And for animals, I just have a lion and a buffalo. So with this, we can then run our example. We can run this example and see the type of update that we get. Let's scroll down. I'm going to collapse this. And just under here, I'm going to call run example. Not fun example, run example. I'm going to call run example. It expects a name. So the name, which is the name of our example, I'll set that to no reducer. Next is our state schema. And I'm just going to give it the state without reducer. That's the state schema we're going to be using. Next is our node function. And we're going to set that to the node function that we declared here, or we defined here. And finally, our initial state. Our initial state, and we're just going to set that to the initial state variable that we created. So yeah, we have oh, missing a comma here. Okay, good. So the name is no reducer. The state schema is the state schema that we created, which is state without reducer. The node function that we need is node to update, and our initial state, we've defined it to start count at 5, and the animals as the animal list as lion and buffalo. Want to update through our node to set the count, to increment the count by 1, and to add cats to the list of animals. So let's see what we get. So I'm going to pull up my command line, and then we can run our reducers file. So I'll say python reducers.py. Python reducers.py. Let's see what we get. Open no demo errors. And yeah, running example no reducer. Running example no reducer. Now our initial state has count at 5, and it has animals as lion and buffalo. Those are the 2 animals in the list. But look at what happened with our final state. Count is set to 1, and animals is set to cat, which is the update that we sent in, which is the update that was sent in, showing that it just took the update that we sent and used it to override our existing state. It didn't perform, it performed an update, but not the type of update that we want, and which is what the default reducer does. It just replaces what is existing with the new thing that is being returned. So you have to take note. If that's the behavior you want, that's totally fine. But if you don't want that, you need to define custom reducers for your state variable. Now, here definitely this is not what we want. We want count to be incremented, and we want our animals list to be to have the new input appended to the existing list. So for that, we need to write a custom reducer, and that's the example that we're going to be doing next. So let's close out of this. I run the second example. Let us write the second example. Let's write the second example. So with reducer. Now what we're going to be doing here is that we're going to be writing a custom reducer for our count state variable. Yeah, we'll do that first. There's another. We're also going to be using a reducer for our animals, but I'm going to be bringing a special function for that. But we're going to write a custom one for our count state variable. And like I said, to write a custom reducer is simple and straightforward. You basically use a Python function or a JavaScript function if you're using the JavaScript SDK. So what we're going to do is we're going to say define update count. We call that the name of our custom reducer for the count state variable, update count. And like I said, it takes the new, rather, it takes the current value of the state variable. That's the current value of count. You can type int based on the variable, based on the type of the particular state variable that you're trying to update. But for now, I'm not going to do that. I'm just going to say current. And it also takes the new value, which is the value that's coming from a node update. So it takes those two, and within your function, you can determine how they are updated. You can determine how the update takes place. So this can be as complex as you want. It can be as simple or as complex as you want based on your use case. For this example, we just wanted to add the 2. So increment the current value by the new value. Increment the current value by the new value. That's what we want. That is what we want to happen whenever we send in a new update for this value. So we send that, we do that. Then we then come down here. And I'm going to define another state schema. This time I will call it state with reducer. State with reducer. The first one was state without reducer. And by the way, let us comment out the example so that it doesn't run again. Let's comment that out. Okay. So state with reducer. We give it typed dict. And here we can say count for count. And this is where you use the annotated class, because that's how you add extra information to your variables. So you need to use the annotated class. is the annotated class. And the first thing that goes in is the type. The first thing that goes in is the type. So it's type int. And the next thing that goes into this list is, or this definition, is your reducer. Anything you put here is going to be automatically recognized by LangGraph as the reducer for this state variable. Anything you put after the type int is going to be automatically recognized as the reducer for this state variable. So here we're going to add update count. And no, for animals, for now we're not going to add any reducer, but we're going to be adding one later. But for now, I'm just going to leave it as a list of strings. So now we have this state reducer, which is good. Now we can run our example. Once again. So I'm going to come down here and call run example. And for the name, we'll say with reducer. The next argument is our state schema, which now would be the new state we just defined, state with reducer. And after that, we are going to have our node function, which is the function that we also used there, node to update. And finally, we're going to have our initial state. And we'll set that to the initial state that we defined here. So our count still starts at 5, and our animals list contains a lion and a buffalo. But now we are working with a reducer. Only for count for now. We're working with a reducer. So let's see how this would turn out. Let's pull up our command line. Let's clear this. And now let's run this example. So now we have our initial state, which has count at 5, and animals with a lion and a buffalo. But in our final state, we now have count at 6. And if you remember, our node updates our state by returning 1. Yeah, this is our node. It updates our state by returning 1 for count. And what our custom reducer did was that it took that new value, which is 1, and added it to the current value, which is 5. And now we have 6. So our custom reducer is in action. But we didn't specify any reducer for animals, so we still have it as cat. So with that, the default reducer is still in effect. But what if we want to also give that a custom reducer? For that, I'm not going to be defining the custom reducer. I'm just going to be bringing in a very wonderful library called operator. So we'll say from operator, import add. So I'm going to bring in the add function from operator. Then we'll come down here and say for this animal's definition in our state with reducer, we want to annotate it. The type is still going to be a list of strings, but now we want to add a reducer by using operator's add function. So you can actually bring functions from other packages, whether custom packages or packages you pulled using pip. Yeah, as long as they are pure functions. And they follow the signature of state reducers. They have to follow the signature of state reducers. So animals, we have it as a list of strings, and now we have added the add function from operator. So let us save this, and now we can run the example once again. And pull up the command line. Let's clear it up. And now when we run our reducers file once again, initial state, count is 5, animals as lion and buffalo, and for the final state, count becomes 6 using the custom reducer that we wrote, which was already working fine. And now if you look at the animals list, you see that cat is now appended to the list. Yeah, cat is now appended to the list. It is no longer overriding the existing value. How amazing is that? So that's basically how reducers work in LangGraph. in LangGraph. And like I said, LangGraph also provides this add messages reducer that you can use to manage messages from an LLM. But in this video, I hope you have understood clearly how to use reducers in your LangGraph agents.